take a few minutes here and record the activities that we've done over the past 2 days, or will do over the past 2 days, the Wednesday and Thursday portion of the class. ICND2, the second review. In Lesson 11, Module 11, which was a very long one, we talked about and did labs on routing protocols. We had two types of routing protocols: distance vector and link state. Distance vector are known by the fact that they send the entire route table on a regular basis. RIP is a distance vector protocol. RIP, distance vector protocol, updates every 30 seconds. So it's a pretty chatty protocol that would be okay in a small network, and as you recall earlier, it has a hop count of 15, so a hop count number of routers that can be in it, so it's not something that's going to work in a very large network. The link state protocols, what I call the more advanced ones, are the ones that base their updates, their information sharing on the state of the links with their neighbors. They establish neighbor relationships and share information with each other. We have interior protocols and exterior protocols. Interior protocols managed by a single entity, a single administrator. Exterior protocols are those outside of us. The exterior protocol that we're probably most familiar with or would like to know more about is BGP Border Gateway Protocol, which is the protocol the internet runs on. Interior protocols, the ones that Cisco wants you to know about, are EIGRP, OSPF, and RIP-v2. The other type that we have are hybrid protocols. The hybrid protocol is EIGRP. It exhibits the traits of both distance vector and link state, and the distance vector trait that it exhibits is on initial startup it gives its neighbors its entire route table. Other than that, it is a link state type of protocol. OSPF, Open Shortest Path First, is a standard, establishes adjacencies with its neighbors using hello packets, link state protocol, in a broadcast, in a domain, or a broadcast domain. If they're all basically all on Ethernet that get broadcast, it's going to elect a DR and a BDR. A DR is a designated router, BDR, backup designated router. It will then use multicast to update the member routers would update the designated router. The designated router would then send the updates to the other routers. The BDR, the backup domain router, is there in case something happens to the designated router. Then it will assume the duties and elect a new backup designated router. The process ID is necessary in OSPF when we do an OSPF or router OSPF at the config line, and then the process ID. The process ID is there for the router to keep track of OSPF, of that OSPF process. It is locally unique, and you don't have to use the same one on all of the different routers. We use areas with OSPF to define which routers are going to share route information with each other. We have to have a backbone area. Area 0 has to be the first area that we created. All the other areas must touch area 0 when we have others, and we have multi-areas. Switched virtual interface for VLAN routing, we looked at that. What the switched virtual interface does is to allow us to use a layer 3 switch to create virtual interfaces, and then it does the switching between IP addresses inside it. Differences between routers and switches, switching hardware, routers routing hardware. the end effect is the same, but the process is a little bit different. But what we have to have are trunk ports, obviously, for our individual switches that have VLANs configured on them. Those VLANs need to be configured on the layer 3 switch, and then we create the virtual interfaces. And since that all of the interfaces that we create there with the IP addresses are local to the switch, then we don't have to use any routing protocols in order for it to be able to allow communication between the different VLANs. OSPF2 adjacency, the routers establish adjacencies, have neighbors. If we have a serial connection, point-to-point connection, we're not going to have a DR and a BTR. It does these things with link state announcements, a number of link state announcements in each of these things, and then we again have areas. The first area has to be 0, and we allow all of the routers within an area to communicate with each other. We have an area border router between areas if we have multi-areas that will allow communication between the two areas. And what these are going to do is have a NIC in each area. So if we had area 0 here and area 1 here, we would have a router here with an interface in area 1 and an interface in area 0. And then the area border router will send routers across each of these. So, and when you excuse me, when you see them, if you see IA inter area, that means that it came from a different area. We have inter area capabilities with these things. They can share between routers. OSPF v3, which is IPv6, we configure at the interface, unlike OSPF v2, IPv4, where we do OSPF and then the autonomous system number, and then enter, and then we do the network, whatever the network is, and then specify the area. OSPF3 we configure at the interface, so all the interfaces that have OSPF v3 configured on them are going to be in the OSPF area. In any case, IPv6, OSPF, and EIGRP will get to it. Need a 32-bit router ID, a 32-bit RID that we have to configure on it. Looks just like an IPv4 address, but they have to have separately configured a router ID. EIGRP, Enhanced Interior Gateway Routing Protocol, is an enhanced version of the old IGRP, Interior Gateway Routing Protocol. Cisco proprietary. It has K values that are used to calculate the metric. There are 5 of them, but we only are going to use 2 of them, which is bandwidth and delay. So bandwidth and delay are used to determine the metric for EIGRP. We have an autonomous system number when we configure EIGRP router, EIGRP, and then the autonomous system number, and then we advertise our networks. Autonomous system means that if I put a router in autonomous system 30, it will only communicate with other routers in autonomous system 30. So we create the autonomous system in order to, I guess, reduce the span of how many routers are talking to each other, how much traffic we're generating. This one, another multicast communication, and EIGRP only communicates updates when something changed. Auto summary summarizes the network. It says summarizes routes on the router, summarizes the networks on the router as they go out of the router to the nearest class full boundary. If we want to know if auto summary is on or off, we can show IP protocols. And in the new routers, it is configured to be off by default. In older routers, it's going to be on by default. We have hello messages that check to be sure that the neighbors are still there. And if they fail, we go through a hold time, and if the hold time expires, it presumes that the router on that interface is down. Hello messages also include goodbyes, and a goodbye is used when we down an interface or a network. What it does is tell the neighbors that we've locally terminated the process, and we use these hello messages to try to expedite the convergence in the network for the network changes. What it tells it is expect a topology change coming, go ahead and get ready and do it. It doesn't have to wait for the timers to expire. Routing protocols. In EIGRP, we have a route table and a topology table. The route table has routes. The topology table is going to have the backups. We'll get those in just a second. But the topology table is going to have the successor routes. Successor routes are the successful ones, as well as the feasible successor routes, which are backup routes. The successor routes and the feasible successor routes are both going to be listed in the topology table. The successor routes, the ones that we're going to use, the best routes, the best paths, are going to only be in the route table. Successor and feasible successor in the topology table, only the successors are in the route table. We have two different distances here, the reported distance and the feasible distance. The reported distance is always going to be less than the feasible distance. The reported distance is what the neighbor tells you it costs it to get to that network. So the feasible distance is the reported distance from the neighbor plus whatever our costs are to determine the metric that goes to the individual into the networks. The lowest feasible distance is going to be the successor route, and in EIGRP, external EIGRP administrative distance is going to be higher than the internal. The internal is 90 and the external is 170. If we redistribute routes into EIGRP, those routes will be external routes and hence have the higher administrative distance. EIGRP v6 by default is in shutdown mode. We have to give it a no shutdown command in order to turn it on. It also is configured on an interface basis, just like OSPF version 3, the IPv6 version was. We need an autonomous system number in order to know which other routers to share our information with. So we have to configure the autonomous system number for IPv6 and then go to the interfaces and add the protocol to the interfaces. That activates the protocol on the interfaces and advertises them. And just like in OSPF, it needs a 32-bit router ID in order to function. So the next was HSRP, Hot Standby Routing Protocol, or a First Hop Redundancy Protocol. Standby command, we use standby to configure it, standby to troubleshoot it, and standby is the command that we use. In this configuration situation, what we're going to have is a virtual router in here and two physical routers. A virtual router in here will have a virtual IP and a virtual MAC. The virtual router decides which physical device to send the information to. We use a standby command on an interface, standby, and then a group number. Then we configure an IP address, and that IP address is going to be the virtual IP. And once we do that, we use that as our default gateway. Once it gets to the virtual router, it will decide based on the priorities that we have established, and the election of the two devices, whether it's the active or the standby, which one to send the data through. If it's the active is going to go there. The standby is just sitting here waiting for the active to fail so it can take over the job. So we have active and standby routers in this thing, and those are the physical routing devices. And then the virtual router, which we talked about here, the preempt is not a default in HSRP. It is in VRRP, but not HSRP. We have to configure it. The priority, we configure the priority 100 as default. If we want to force one of these routers to be the active router in the standby command, we can assign a priority of maybe 120, and then we do a standby again, and we give it the preempt command. Preempt command allows a router with a higher HSRP priority to take control of or become the active router. It sends a coup message, and then the other router that has been preempted is then going to resign. We can have one active, one backup, and any others that are configured in the HSRP group are going to be in listen mode. The highest priority is going to be the active router, and this is another one we can configure it if we don't make any changes to it. It's going to go back to the highest IP address for the election. For more of HSRP in Lesson 5, cloud services. We talked about software as a service, platform as a service, and infrastructure as a service. Access control lists. We had the standard and extended. Standard was based strictly on the source IP address. The extended, we could use source and destination address as well as the TCP or UDP ports to control access to a resource, a web server, for instance. Access control lists could be time-based. That the events in the list occur in an authorized time slot after we have the permits and denies. Then we can specify what time that this portion of the access control list will be active. Maybe you want to allow somebody to telnet certain hours of the day. Then you would specify that on the time, and then do a permit port 23 during that particular time. VRRP, Virtual Redundant Routing Protocol, is the standard. It uses a master and a backup. And in this one, unlike HSRP, which could only have one router that was not in the active state, in the standby state, this one can have multiple backups. And same thing, the active one goes down, the backup takes over. VRRP by default, preempt is enabled by default. It still uses the 100 for the 100 for the default priority. Quality of service. What this does for us is allows us to assign priorities to traffic. We mark the traffic. First, we classify the traffic to mark, and we classify it with a class policy. And we're going to use access control lists in order to classify the traffic. So then we have a policy after which traffic we're going to do. We mark the traffic, and then after we mark the traffic, a service policy will apply the policy to the traffic. We use these for congestion management, congestion avoidance, so that we allow the high priority traffic to have the higher priority. And also in voice, we avoid some of these nasty things down here like latency and jitter. Latency is delay. Jitter is an inconsistent jitter where we have voice phone calls which are maybe unintelligible. Bandwidth and packet loss are other things that we can look at in it. The Cisco trust, device trust, is off by default, and what that's saying is that we are going to trust the marks from one device to the other. By default, that's not going to happen. Two different methods to do this. One is policing, and the other is shaping. Shaping is when we kind of buffer, I guess for lack of a better word, and then send the traffic, catch up with the traffic when we have some lower demand times. Policing will it's either on or off. Once we go above the limit, then we're not sending anything. When we come back down below the limit's established, we start sending again. 7 was SNMP. We have the manager and the agent. We looked at this earlier in the ICND1. Get and set message is used for a read-write community. Well, a set is when we want to get information, we use a get message. In order to do that, we have read-only and read-write communities. The MIB is the management information base, which has all the devices listed in it that we're going to monitor. The new version of SNMP is SNMP v3, which has integrity, authentication, and encryption. So SNMP v3 has security attached to it, where versions 1 and 2 didn't. They strictly use a community name in order to determine which devices to talk to. The last lesson in this grouping is lesson 8, TACACS and Radius. TACACS uses TCP, Radius UDP, just some kind of overviews, I guess. We do authentication, authorization, and accounting. Unlike if we use the local logons down there at the bottom, if we use the local database, we don't have any accounting. We need the servers in order to store that. And the Radius, open source, Microsoft runs Radius, is available on the servers by default. There are open Radius softwares that you can download. TACACS is a Cisco proprietary. TCP, probably a little more responsive to Cisco devices than Radius is. In order to use these devices, we have to establish a new AAA, a new model for AAA. So we go in and use the AAA new model command, and after that we do a methods list. The methods list is just a list of authenticating measures, authenticating procedures that we're going to use in order of precedence. And it doesn't mean that if I log on and have a bad log on, forgot my username and password, that'll go on to the next one. If we, for instance, put Radius first, and the Radius server becomes unavailable for whatever reason, is not responding, then the method list will go to the second method in the methods list. So it might be authentication, default, Radius group, and then local. So if the Radius wasn't available, it would look in the local database. And again, the last one there, if we use the local authentication, there is no capability to do any accounting on it. Counting, obviously, what we did. Authentication, prove who we are. Authorization, what we can do. And accounting is a record of what we did do. So that's a quick overview of what we covered in the last 2 days of the class. Not the last 2 days, but the Wednesday and Thursday of the class. So are there any questions?